Hi, Assalamualaikum. Today we're going to do the topic 10 in the MEM575, in which we'll cover the topic of reliability and maintenance management. So for learning objective for this topic is to understand the maintenance, reliability and its enhancement, and also to able to differentiate types of maintenance in which we'll recover the preventive breakdowns and also other maintenance, and also understand the total productive maintenance. So maintenance means that all activity involved in keeping a system equipment in working order. So maintenance will be involved in the manufacturing, okay, on the production line and also in the building. Okay, so maintenance is needed almost in all of the system. And reliability means that the probability that a machine part, okay, or the product will function properly for a specific time. And the objective of maintenance and reliability to maintain the capability of the system while controlling the cost. Because if we are not controlling the system in a good manner, so the cost of breakdown will occur. And there also are the costs that will involve. Tactics to improve reliability and maintenance, in which maintenance, implementing or improving the preventive maintenance, and also we need to increase the repair capability and also the speed. So we need to reduce the downtime. And for reliability, improving individual component, and also we provide redundancy of the system, maybe a backup system or a parallel system. And reliability means that systems are composed with series of individual interrelated components. Usually in the system, we have lots of components. And if one of the components fails to perform, for whatever reason, the overall system may fail suddenly. Okay, example for a complicated system such as for an airplane, a turbine. Okay, all of these, they have lots of components. So the more components you have in series, so the reliability of the whole system will reduce. So it's become more complicated. The system reliability need be to determine, in which we need to calculate the system reliability, in which when the system is in series, it means that the reliability of component 1 will times the component 2 and until all the component involved. So you can get the whole system reliability. Okay, these are the simple example on the calculation of reliability. For example, the component 1 is 0.9, and then the next component is 0.8, and the third component is 0.99, the reliability. So the reliability system going to be 0.9 times 0.8 times 0.99, so we get 0.713, in which means that 71.3% reliability of the process. When we talk about redundancy in reliability, we want to make sure that what if one component or one of the paths fail, the system can sustain. Okay, so maybe they recourse to another, and it can be in the form of backup component, in which you have backup redundancy. For example, R1 have backup component, okay, and R2 have backup component. And also parallel path, in which they have parallel redundancy. So for example, they have 3 parallel paths here. So let's say one breakdown or in maintenance, so the other 2 can support the whole system. And let's see on the calculation for backup component or backup redundancy. For example, these are the early one that we calculated, in which we get 0.713 for the reliability of the process. Now we decide to have a backup redundancy, in which for R1 we have a backup system, and R2 also a backup system, and RT maintain the same. So what are the reliability of this new system when you have the backup redundancy? So let's calculate this. So the calculation is totally different from this one, because this one have no redundancy or backup. So what you have to do first is to get the reliability for the component with the backup first. Okay, so we're going to do R1 and also R2 separately. So for R1, first we need to find the failure first. So the failure for the each component, okay, the backup and also the working components. So since 0.9 they have the same reliability, so 1 minus the reliability, okay, we power with the power of 2, so we have the failure for this system is 0.1 square, and then we have 0.01. And also do the same thing also for R2, in which we have 0.8, so same reliability here. So we need to find the failure first. So 1 minus the reliability, since they have the same reliability, so we squared here, so 0.2 squared, so we got 0.04. Okay, once we have the failure, then we can determine the new system reliability when they have the backup. So 1 minus 0.01, so we get 0.99, and this one is 1 minus 0.04, so we get 0.96. So 0.99 is the new reliability for R1 with the backup, and 0.96 is the new reliability for R2 with the backup. So R3 have no backup, so we want to determine the system reliability. So we just take the new R1 0.99 times the new reliability 0.96, and this one we are going to take 0.99, so we will get 0.941. Okay, these are the new reliability compared to the previous one without the backup redundancy. So it shows that the reliability have increased from 0.713 to 0.941. Okay, so you can see that the backup helps to increase the reliability of the system. Okay, what if we want to calculate the parallel path or parallel redundancy, in which, for example, these are the parallel circuit, and here we need to solve this. What are the system reliability? What are the RS? So first, when you have this kind of situation, you need to solve for this one first, the R2 and R3. So we need to solve this one to get the R2 and R3 reliability. So 0.975 times 0.975, so you get 0.9506. So these are the new parallel system. So we need to calculate the reliability. So by parallel, so first we need to find the failure, okay, for the each of this reliability. So the first one is 1 minus 0.95, the second one is 1 minus 0.906, and the third one is 1 minus 0.95. So the failure for this 3 is 0.00012. And now we want to find the reliability of this system is 1 minus 0.00012 from here. So we get the reliability of the system is 0.9998. Okay, I prefer this way because it's very clear and easy to understand. Okay. Okay, now what is maintenance? So we done with reliability. Why maintenance is important? Because it's need to sustain or maintain the capability of the system. So make sure it in the working order. Prevent work stoppage, in which caused by the equipment malfunction. It will stop the line. Definitely the cost. So the cost we need to reduce, especially for the breakdown cost. When one of the machine breakdown, we will have lots of other costs, for example, idle time, waste, disruption, scrap, and so on. And ensure the entire working place is safe. So you need to do the maintenance to prevent the accident. Okay, you need to know the types of maintenance. The first one is breakdown. So it's not a very effective way of doing the maintenance, in which is considered as the corrective or reactive approach, in which you deal with the breakdowns when it occurs. So you don't know when it's going to happen. So it will cause lots of problem later on. And the best one is preventive, in which is proactive approach. Try to reduce the breakdown through a program in which you need to do the lubrication, adjustment, cleaning, inspection, and also replacing the wear and tear parts. So you do it before it breaks. And the best is predictive maintenance, in which it's most on the condition-based maintenance, in which to predict, and also perform preventive maintenance so that no breakdown will occur, in which they're using the data from the vibration, temperature, pressure, and noise, in which they feed into big data system, and they can predict when is the best time to do the preventive maintenance and reduce almost to zero breakdown. Okay, let's look at the breakdown maintenance. What are the costs? The cost of downtime, okay, probable loss of sale. We have the cost of the labor, when the labor idle, don't do anything, okay. Cost due to delay in other processes, scrap will occur, repair costs, especially when you have no spare part and so on, and also customer dissatisfied because of the delay. Okay, once this line stop, so you will have a delay. Standby or backup equipment that can be quickly pressed into service. Okay, inventory of spare part need to be on hand, and operator must be able to perform minor repair and ensure maintenance workers are well trained. Okay, these are the best program that if you involve in the breakdown, so everything must be ready because we don't know when the breakdown gonna happen. And for preventive maintenance, monitoring, and then also perform routine inspection, servicing, and keeping the facilities in a good repair, in which we want to reduce the potential breakdown. Okay, and these are the elements in which we have the routine maintenance, we have the periodic inspection, and also monitoring. So the maintenance crew will go around the production line to do the routine maintenance, periodic inspection, also monitoring. So for the predictive maintenance, okay, it more on the condition of in the service equipment, and they are using data collection, big data, and then they will detect early default detection, and then they will predict the time to failure, and they will do the maintenance scheduling. Okay, so usually they have a system to help them to do the detection. And also predictive maintenance differ from preventive, in which it depends on the actual condition of the equipment, and to predict maintenance will be required. So that's the difference between predictive and preventive. Predictive, you need lots of data. Okay, preventive, you have a need to do the scheduling of the program. Economy for maintenance, okay, so for highly complex automated machine with the expensive part and highly skilled labor, in which, for example, you have a big system, you have the turbine, okay, you have the power system, so the best is to have preventive maintenance before it breaks down. Usually preventive maintenance can be done using while the machine is idle or in a low production time, not at the peak time, okay. And sometimes there are systems that when they shutting down, the machine is going to be high, so they have to wait until it's breakdown. Okay, let's do some calculation. Preventive versus breakdown cost comparison. Sometimes it is best to have preventive to hire the third party, or just to let it break down. So these are the example of printer maintenance, in which the company whether want to decide to hire a firm or a third party to do the maintenance for their printers, or just leave it to break down. Okay, so with the maintenance, monthly service to be paid is 150 ringgit. So these are the number of breakdown. These are the data in which the number of months when the breakdown occur. So 0 breakdown, they have 2 months with 0 breakdown, and then 1 breakdown per month, they have 8 months. Okay, and then for 2 breakdown per month, they have 6 data, 6 months, and also for 3 breakdown per month, they have 4. So they have to total up the number of months in which they have 20, and average cost of breakdown is 300 for every time. So let's say for a month they have 4, so they have to time 300 times 4. And routine serving cost, okay, this one for the third party is 300 per service. So let's do the calculation. First, you need to compute the expected number of breakdown. So we have the data here. So number of breakdown, and then we need to find the corresponding frequency. So what we have to do is take this number of months that break down 0. So 2 over 20 from the sum. So we get 0.1 and do for the breakdown 1, 8 over 20, 0.4, and then 6 over 20, 0.3, and the last one is 4 over 20, 0.2. Now we're going to use this formula. So number of breakdown, this one, and times with the corresponding frequency. So for this one is 0.0 times 0.1, 1 times 0.4, 2 times 0.3, and 3 times 0.2. So you add up, you get 1.6 breakdown per month. Okay, once you get this one, expected number of breakdown, then you will use it to compute the expected breakdown cost per month without no preventive maintenance. So it means that without having the third party to do the servicing. So the cost is going to be expected breakdown per month 1.6 times 300 for every breakdown. So average about per month they spend 480 ringgit per month. So what if the cost with the third party hire? So when we hire third party for the cost of preventive maintenance, so here they say that one routine per month costs about 300, and plus the 150 is for the maintenance service. Okay, so 300 plus 150, so you get 450 per month. So you compare this, which one give you the lower cost? So it shows that the cost preventive maintenance give you lower cost, so you need to conclude that hire the service firm is better, in which they will give the lower cost. Okay, in the maintenance policy, for example, critical component is replaced before it breakdowns because it will cause lots of trouble. Okay, and make sure you have a very good repair facilities and also have a good crew, very efficient crew to reduce the downtime of repairing, and also have a parallel path. Design a critical component in which they will give a more higher reliability. Establish storage or buffer in between lines if one of the machine down, so the other machine can still work. And also use a standby machine, especially the machine that always have problem. Okay, we have looked into the breakdown, we have looked into the preventive, predictive, and now we're going to talk about the total productive maintenance, in which it related to the TQM. So TQM with the preventive maintenance, we call it as the total productive maintenance. So the keyword for the TPM is the autonomous maintenance, and in which it involves the operator. So the operator have responsibility to monitor and also to decide whether the maintenance is needed, okay, for their system. It will predict failure, prevent breakdowns, and also prolong the equipment life. So direct employee involvement is very important, in which the sense of ownership, so that the operator will care more about their machine, and also they will organize all the operation, preventive activity, and also they have the training for the maintenance, simple maintenance, and proper documentation in which they have a proper SOP, and also they have the expert system to troubleshoot at the machine. And how to implement TPM, in which they have to design the machine, must be easy to operate, easy to maintain, and have high reliability, emphasizing total cost of ownership, in which the service maintenance is included in the cost, and also they have the maintenance plan, in which involve the operators and also the maintenance crew. And also the training for autonomous maintenance must be offered to the operators, so that they know their own machine and also they know how to troubleshoot. And from the TPM, it can convert into computerized, in which they have simulation system, okay, for complex situation, and also they have the expert system to help them in identifying the problem and select the root cause, and also they have the sensor to assist in the monitoring. And these are the best practice in maintenance, in which they have all the computerized maintenance system, in which all the historical data on the repair, okay, on the scheduling, inventory, spare parts, and then about the maintenance crew, in which they can organize whenever they have the preventive program and also the breakdown. So we have covered the maintenance, reliability, and its enhancement. Also, we have differentiated the preventive, predictive, breakdown, and also we go a little bit on the TPM.